So this video is for IM2, day 49, number 7, where we're talking about composition of functions. So before we start, I just want to review, whenever we're looking at a function, so this is a function f of x, here's a function g of x, it's all about inputs, okay? So this is saying, here's a function f, if I put an x into this function, here's what I get out. So I take whatever my input is, I square it, then I subtract it from itself, and then I subtract 2, no matter what the input is, all right? Same here with this g function. If I put in some x, I multiply it by 3 and add 5. That goes for any x that I put in there as long as it's in its domain, but we're not going to worry about domain for this problem. So what we're going to do here is we're going to see, just focus on inputs, and see what happens with our functions. So what I'm going to do first here is for part A, where we've got f of g of -2, is I'm going to use this kind of color coding that I've put up here and see if it helps. So I'm going to write the f function in red, and then I've got g of -2 there, and then I'm going to close my red brackets. So I think this makes it a little easier to see that first we're going to start on the inside here and we're going to put a -2 into the g function. So let's just see what happens there. So I'm going to leave my equals sign. So I'm going to keep it red because I haven't done anything with the f yet. But now let's figure out what the g is. Now, if I put -2 into the g function, that's only just going to look like this, a -2 in there. Oops, and I want to make that a red bracket because I have finished with my g function and now I am only dealing with the f function. Let's do a simplification step. So we'll leave the f there, and on the inside it's just going to turn into a -6 plus 5, so a -1. So that's what I got out of that -1 here is what I got out of the g function after I put a -2 into the g function. Okay, so now I need to do put a -1 into the f function. That's going to look like this, and we can leave it all red now because we're just dealing with f. It's going to be a -1 squared, right? I take it, I square it, then I subtract it from itself, then I subtract 2. What does that come out to be? Well, -1 squared is 1, so 1 minus a -1 is a +1, minus 2 is going to give me 0. So that's all there is to it with these problems. You just concentrate on what your input is and go piece by piece, start from the inside and work your way out. So for part B, what we've got is g of f of 0. So for part B, we've got g of f of 0. And let's go ahead and put that in our colors again. So g of f of 0. So hopefully the colors help, but what we're going to start with this time is that f function, and we don't care about g right off the bat, so we'll leave g alone. And now I've got to do f of 0. So what's f of 0 going to look like? 0 squared minus 0 minus 2. All right, and so if we keep going, that's going to be g of, what did all that in the middle turn into? Just a -2. So that -2, again, is just whatever f of 0 is, right? We put 0 into the f function, we got something. Now we need to take that and put it through the g function. So when we do that, we're going to get 3 times -2 plus 5. That becomes a -6 plus 5 is a -1. So there's A and B. C is trying to get a little trickier on us. So what C is doing is not giving us a number. It's leaving the input as just a variable, which is okay. We can handle that. So f of g of x. And this is where the color coordination is really going to come into play. So let me give myself a little more room here. So I'm going to shrink this stuff. Just move it up. Just give myself a little bit more room. So let's color code this. So f comes first. So f of g of x. Close it in the red. Okay, so it looks a little different, and I know it might be a little scary because there's no number in there, but it's nothing we can't handle. So let's just do everything the same that we did before. So what is g of x? G of x is just 3x plus 5. That's it, all right? I know it's not as nice as a number, but and we're going to have to learn to deal with variables a lot more coming up. So that is my g of x. I'm using that as my input now into f. So what happens when I put 3x plus 5 into f? Well, I've got to square it. Then I subtract it. And then I subtract 2. That's it. Now be careful. One thing I would really recommend when you're doing things like this is make sure you always leave parentheses when you sub in this for x up here, okay? So you always want to leave these parentheses just because this negative is going to distribute and make a mess, and if you didn't square this whole term, you'd get the wrong thing. So for this problem, we can just leave it like that. There could be some simplifying that can happen here, but we don't need to worry about that right now. What we're really concerned about is just getting the composition of functions down.